Your stomach has columnar cells also. So this is simple columnar epithelium. And up here now, this is a bit of more of a mess. Now you have real cilia. These are the real cilia. Look at how different they are than fuzz. Okay, so you saw this on your trachea slides, right? But remember how little they looked? They were small, and they were kind of stuck together. This is nice and resolved here in a nice way, but your slides, it was not so nice to try to look at them. Okay, and they lined the trachea, sweeping out the dust and mucus up towards your mouth so you could go and spit out or swallow it down into the stomach acid. That's what you do. But the cilia do that sweeping action. Okay, now look at this. This is a nice goblet cell. A goblet cell. Goblet cells have what in them? Mucus. How about a nice goblet of mucus? Yeah. Okay. They're putting out mucus. So your trachea has mucus in it. You coughed up mucus, you know what it's like. And the cells now, look at all the nuclei. What kind of cells are these? Are these multiple layers or one layer?
One, looks like one stretched out there.
These are one layer, but they're faking you out as much as they can. These are pseudo-stratified. They're not truly stratified, they're pseudo-stratified. So these are pseudo-stratified and they're columnar in shape. So this is now, got to get it, ciliated, pseudo-stratified, columnar epithelium. And where are we? Tracheal lining. So now I can ask you that. What's the lining of the trachea? Ciliated, pseudo-stratified, columnar epithelium. What's epidermis? Yeah, it is, but so is the dermis. Epidermis plus dermis equals skin. So what's epidermis? What tissue would it be?
Stratified.
It's stratified because you don't want to lose it. You scrape a little off, you don't want to lose it. Ciliated, pseudostratified, squamous.
Skin?
Yeah. The epidermis is.
Epidermis is cilia?
No, did I say cilia? I'm sorry. It's, I left a word off. Keratinized, stratified, squamous epithelium. Keratinized means it's tougher. It's got keratin in it. Remember the granulator was stuffing keratin into the cells because you don't want to rub off all your epithelium of your epidermis, so you make it thicker. So keratinized, stratified, squamous epithelium. That's epidermis. Keratinized, stratified, squamous epithelium. Epidermis. There's more stuff here, hopefully we'll get back to it. But I wanted to show you those. So now you've seen the different kinds of tissues, mostly. Oh, no, we skipped one. We got another one here. So, there we go, this is page 122. 122. Okay, what do you think about this? Where are we? We're in the esophagus and the mouth cavity, the oral cavity, yes.
So did you say the epidermis?
Epidermis was keratinized with a K. Keratinized, stratified, squamous epithelium. You're welcome. So here, we're in the oral cavity, the mouth into the pharynx, and we are certainly not simple, are we? What is this? Stratified, what kind of cells? You say, well, these look a little bit cube-like. No, you go to the top to decide. So you go to the top, now they look like pancake cells, don't they? So now tell me what it is. Keratinized, stratified, squamous epithelium. Keratinized, stratified, squamous epithelium. There's keratin in the cells that are on the top part, and they'll rub off, they'll slough off as time goes by. You lose cells that way. Remember the granny layer? Then there was another layer above that that could be missing. And then the top was the corneum, stratum corneum. That's the most of it right there. And those are dead cells with keratin in it. Okay? So, you know that when you're eating potato chips, when you're eating pretzels, you're going to get scraping going on down in here. So you need this cushion of cells so you don't scrape it all off. Okay? So this was stratified squamous epithelium. Okay? If you're out on the skin, it's keratinized stratified squamous epithelium. In here, we really are not crazy about flakes. Okay? So it's less likely to be keratinized. Who wants flakes? Okay, so now the bottom is quite interesting. So today, in a little less than an hour, about an hour, you're free to go for your party in Tallahassee. Isn't that exciting? Takes how long to get there? A few hours, 2 or 3 hours? Okay, so you're gonna go to Tallahassee. You're driving or you're riding with your friends to go over there. So you decide to drink a gallon of sweet tea before you leave, or eat a watermelon. What's gonna happen? Predict. You're gonna have to stop at the roadside rest, okay? Well, what does your bladder look like before you stop? Right? Okay, does that mean it has to stretch?
Yeah.
And does it mean it has to come back again?
Mm-hmm.
Yes? Well, this is what you need. This is what you need. This is transitional epithelium for the urinary bladder and related structures. And this stretches good. It stretches out good and it comes back again. Now, how are you going to recognize this? This is my way of recognizing it. They look kind of balloony. Don't they look a little balloony to you? Yeah? Well, that's how transitional epithelium looks. A little balloony, especially up at the top. See, we got a basement membrane here. If you flip back different ones, you're going to find a basement membrane on some of these. There's one. That's a basement membrane at the top there. And so you can see that. But that transitional epithelium is kind of interesting. It can stretch out to where it's more like 3 cells thick. It's more than that here right now. But it gets to be 3 cells thick. You're probably looking for a restroom at that point.
What was the basement membrane?
It sits underneath the epithelium. And then the basement membrane is above, usually connective tissue. Remember that one in the GI tract, the digestive tract? I said you have the epithelium and it's sitting on a loose areolar connective tissue, which we call lamina propria. Remember that? It's a lot of stuff, but you keep working on it and you'll get it. All right, do we have enough for a quiz?
Yeah.
Well, we need more. We need the brain. We're going to brain now. I didn't want to stay on that very long because you get your hopes up. Okay? So we're going back to brain, back to the future. Okay, so this is chapter 12, which we already started. And we want to go here. If you were out in the kitchen and you saw something like that on the floor, what would you do? You'd step on it, or you'd call somebody and say, get that thing. Okay, that's how it looks. But actually, don't do that. That's your developing brain. And it looks a little weird, but it's not harmful. Okay, where did it come from? It came from a tube. You didn't know that, your brain came from a tube? Yes, and your spinal cord did too. It's called the neural tube. Neural tube. Yeah, looks like a tube. As it starts growing, it gets a little weird shape. And this fluid in here is what? Cerebral spinal fluid. Okay. And this will develop into the parts of the brain. And what was that big part over the top? Cerebrum. Okay. And then I want to go from there. Let's, well, I'm changing it. That was 435. As this thing keeps developing, and we love color coding, we just love it. It's not normal, but we love it. Okay. But brain is kind of hard to figure out if you don't have the color coding. Not where I want to be yet. Maybe I skipped it. I probably skipped it. Let's go back. I thought I had a better picture of it. Yeah, I do. Okay. Let's take this from page 450. 450. That's right over here. Page 450. And we've come a long ways. We'll go back to the tube in a little bit. But we've come a long ways. You all would recognize all these squiggles, and this is the one. Okay, they're gyri. What's all of this? Cerebrum. Cerebrum. There's another name for that. Telencephalon. Telencephalon. So this is the cerebrum and all those squiggles. And you know a little bit about this. You know the lobes, don't you? This lobe is, okay, yeah, I'll come back. I'll come back. But I want you to meet somebody nice, really, really nice. The purple one. The purple one. Nice young lady. I mean, really nice. You'd like her. Her name is Diane. Diane Cephalon. That's right. Diane Cephalon. Okay. And it looks like two purple eggs. Well, that's the thalamus. Two purple eggs equals one thalamus. And that's 80% of Diane right there. Okay. Diane is 80% thalamus. And these two together is a thalamus. Not one and another, but both of them together is a thalamus. Okay. So that's 80% of Diane right there. So what's the rest of Diane? What's this thing hanging down here? Pituitary, off the hypothalamus. So Diane is thalamus, 80%. Diane is also hypothalamus. And in the back, you have the who? No? Pineal gland. So pineal gland. So Diane has three main parts, but thalamus is the biggest. Thalamus is 80% of Diane. In the front, you have the hypothalamus with the pituitary coming down below. And in the back, you have the pineal gland in the epithalamus. Epithalamus, thalamus, hypothalamus. Three parts of Diane.
So is the pituitary gland part of that structure?
That's a good question. I'm not sure what they totally include. I'm not sure. You know your infundibulum, and you know this. I would like to say this, but I'm not 100% sure of that. Okay.
What were the three parts of that?
They were, the back end here was epithalamus with the pineal gland, epithalamus. The two purple eggs is thalamus, 80% of Diane. And in the front, you have the hypothalamus coming down here with the pituitary hanging off of it. So the pituitary stuff, the hypothalamus, that is, the epithalamus, that's the other 20%, because 80% is thalamus. And when you get below Diane, you're in the green. The green is brainstem. Green is brainstem, it has three parts. The top of the brainstem is the midbrain. The next part down, it shows better not from the posterior side, but over here on this side, anterior side, this is the pons. Pons. P-O-N-S, pons. So you have midbrain above, that's some of this stuff. You have pons, and below it you have the medulla oblongata. Okay? Midbrain, pons, medulla oblongata, which blends into the spinal cord. Spinal cord. Okay, so that's brainstem. The green stuff here, this is not real green, but it's a little light green. This is brain stem. And you say, well, I don't want the stem, I want the flower. No, it doesn't work like that. Brain stem equals brain. It is brain. Okay? But so is the cerebrum. That's brain. So is Diane. Their brain. Brain stem is just another part of the brain. It's not like, oh, throw away the stem. Who cares about the stem? No. Brain stem is brain. Okay? So if we come back to the neural tube right here, seems like a long way back, that's the neural tube, okay? And it's gonna get lumpy, and it's gonna have CSF inside of it, and it's gonna develop, look like something on your kitchen floor, and so we wanna talk about our parts we were just mentioning. The top is the cerebrum. Another name for that, telencephalon. So telencephalon equals cerebrum. Cerebrum's easier to say. So cerebrum's on top, and it gets big. It has all those convolutions, those squiggles. Then deeper inside, you've got Diane, who often they show ghosted because it's totally covered by the cerebrum. And you have this blue CSF liquid in here in little pockets called ventricles. You have two lateral ventricles, you have 1/3 ventricle, and you have 1/4 ventricle. This is not hard. 4th ventricle, 3rd ventricle, 2 lateral ventricles. And the connection is between 3rd and 4th called cerebral aqueduct. So the cerebral aqueduct connects 3rd and 4th ventricles. But this fluid's on the move. How does it move? The cilia of the,
No.
close,
Wasn't the epilogue?
no? Ependymal cells. The ependymal cells move it with their cilia. Okay? Now the purple was Diane, thalamus, hypothalamus, epithalamus, and surprisingly, I'm going to put this in now, retina. Retina is part of Diane, in your eyes. That's interesting, isn't it? It's like a brain connection to your eyes. Okay, we don't stress that a lot of times, but it is interesting. And the green was all brainstem, starting with midbrain, coming down to pons, which is quite recognizable landmark. And then medulla oblongata. Then you blend into the spinal cord. Cerebellum is not green. Cerebellum is not brainstem. Cerebellum is behind this. Cerebellum's behind the brainstem. Any questions? We're back to our squiggle well tube. I don't want to squiggle. We're back to our neural tube, which is now really thrown into a lumpy mess. Okay. There, the purple inside ghosted is diencephalon. And they ghosted it the next one down. There's Diane ghosted. See, they did it so you could see where it fits. You know it's all covered with this cerebrum. Okay? And the hypothalamus, the pituitary there. What was the pineal gland in? Epithalamus, good. Okay, 80% of Diane is vellum. What's this colored stuff back here? Cerebellum, which is behind the green, like I said, behind the green. Okay, I want to show you something else that makes sense here. If we look at it, just for a moment. Let's see where it's at. Might be after this. Look at this. Yeah, let's go after that. There we go. This is page 482 briefly. Page 482, it turns out while all this brain and spinal cord is developing, actually it comes from here. This is really, really early. This is called ectoderm. Ectoderm. Okay? They color coded it here for you. The blue is the neural plate of the ectoderm. The green is the neural folds, one on each side of the neural plate. Okay, so that's what you see soon when you start into development here. Okay, 2 neural folds, 1 neural plate, which dips down. But it doesn't stop there, it keeps dipping and makes a groove. Groovy here. Look at this, neural groove with the 2 neural crests. So the green turns into neural crest. Okay, neural groove goes ahead and completes as neural tube. So that neural tube is this. What does the neural tube become? Brain and spinal cord, that's right. The bottom end is the spinal cord, the top is the brain. Okay, neural tube. What about the green stuff? The neural crest. It's gonna be PNS. So the tube is CNS, and the green neural crest is PNS. So your nerves are gonna come from that. Okay.
From the green?
From the neural crest. Because it's developing the PNS, not the CNS, that's the tube. Okay. If somebody has a deformity, it could be because of a defect in the neural tube. So that was on page 482. I wanted you to see it, but now I go back to the other part. So now our neural tube means something. The neural tube here, okay? The front end becomes brain, the back end becomes spinal cord. And you see it developing there. And we know about the parts that we were talking about. What connects third and fourth ventricle? Cerebral aqueduct, that's good. Do you know where cerebral aqueduct runs? Right down through midbrain. It goes through the midbrain. So the cerebral aqueduct is in the midbrain, coming down here. Okay, so we see things, we notice that the cerebellum is not part of brainstem. No, it's behind the brainstem. And now they did some good work here that I wanted to point out. Might as well do it in order a little bit here. So I see a butterfly, what do I instantly know? Spinal cord. And the gray matter is what? Neuron cell bodies, and the white is myelinated axons. Okay, you don't myelinate anything else. Okay, and we cut through at places so they can show you what you see here. Look at this cut down through here. You're really cutting things down. And this is what it looks like inside when you make the cut. So you see a lot of white matter. What's the white matter? Myelinated axons. What is this gray matter up here? Neuron cell bodies. It's about an 1/8 inch thick, so it's the cerebral cortex. Neuron cell bodies. Where are your axons? The white matter. They're myelinated and they're diving down here. The axons are diving down. Here we have a space for some CSF, and so this is a cavity in there. These 2 cavities are the lateral ventricles. What other ventricles do we have? 3rd and 4th, good. Who connects 3rd and 4th? Cerebral aqueduct. By the way, this gray matter is down in here. What lobe is that?
No, it's the one that's hidden.
The hidden one? Insula, right, insula.